Well, hello everybody. You've made it to the final video of this review for the spring semester final. And so we have the last couple examples here that we're going to work on. First one here says describe what surface area you would be solving for using the equation 2 pi r h. Well, pi r h comes from the surface area of a cylinder. And the 2 pi r is, so if we had a cylinder and we were finding the surface area of it, we would be finding the 2 pi r h is part of that surface area. And so if we were to unwrap the rectangle that would make up the cylinder and not the circle part, well, this side would be the height, and then the distance around this circle is 2 pi r, which is the circumference of the circle. So the part that we are talking about in this equation, in the surface area, would be the rectangular part that makes up the cylinder, would be what we're solving for. In the next example here, they're asking us to find the area of this regular polygon. And so remember that we are going to find the area of the triangles that are inside, and you will notice that if I could draw all my triangles, there are going to be a total of 5 triangles. So we will find the area of one triangle first. So the area of one triangle is 1/2 the base times the height. And in this case, it's looking like the base is 52 feet. And the height of the triangle is given to me as the apothem there. The height is 42 feet. And so it looks like the area of one triangle would be 1/2 of 52 times 42. All right, so the area of that triangle comes out to be 1,092. And so then how many of those triangles do we have? Well, we have 5 of them. So the area of the polygon, or the pentagon in this case, would be 5 triangles. So it's going to be 5 times 1,092, which will be a total area of 5,460 square feet, since we are dealing with area. Now we need to find the area of this composite figure, and so I'm going to start with the surface area of this composite figure. I'm going to start with the surface area of the cube, or the shape on the bottom. Surface area of the bottom down here. You'll notice that I have one base, which is 12 by 12, so we're talking about this guy down here. There is another one, but I am not going to find, for surface area, I don't need to know the area of that base where the pyramid and the rectangle, or the rectangular prism meet. I just need the area of the bottom. So that is 12 by 12, which is 144. Then I'm going to find the area of all the sides, and you'll notice that this is 10 by 12. This side over here is 10 by 12. If I could draw straight lines, it would be easier. And then this side is also 10 by 12, and so is the left side, and so is the back. So to add up the surface area of this cube, there are going to be 4 10 by 12 sides, which should get me 480 square feet for that. Now we got to find the surface area of the pyramid. Well, we don't need the area of the base, the 12 by 12 base, because it's attached to the cube. So we really only need the area of the triangles here. And so if I was to connect this line over to this side, and then I'll do my best here to draw a line straight up. You'll notice that I have this interior triangle here. And with that interior triangle, they gave me the height is 14. And the length right here is going to be half of that base, because it's to the middle of the base. So that side is 6. The key is I need to find the height of the triangle. And so to continue on my surface area, to find the surface area of one triangle here, I'm going to have to go 1/2 base times height. Well, I know that this base length down here of the triangle is 12. It's 12 on all 4 sides. So the base is 12. The problem is, what is the height? Well, the height we also call slant height. So that is what I'm going to find, and knowing that from the center of the pyramid, to the side is 6, and the height of the pyramid is 14, I can use Pythagorean theorem with this right triangle to find the slant height. So I'm going to say 14 squared plus 6 squared equals the slant height squared. And continuing on with this, I'm going to end up with 196 plus 36 will equal the slant height squared. Combining those together, I believe I get 232 is the slant height squared. And so if I take the square root of 232, that'll equal the slant height, which comes out to be approximately 15.23. So to find the area of the triangle, I have 15.23 for the height. So the area of one triangle is going to be 1/2 of 12 times 15.23. And so I would then multiply that all by 4 because there are 4 of them. And so that would be the surface area of all the triangles of the pyramid itself. And when I multiply that all out, I get 365.52. And if I add all of these numbers together, then I would have my total surface area. So 144 plus 480. And I gotta fix these 4s. Let's try again. 144, 480, and 365.52. If we add all those together, that will be my surface area of this pyramid and rectangular prism put together, which would be 989.52 square feet. All right. And then the last problem on this review is our literal equations, and they're asking me to solve for r in this equation, the surface area equation. So I'm just going to start by rewriting it, just so I have a little room here. And so if I need to solve for r, I need to get r by itself. I notice that r is not only squared, but it is also multiplied by 4 pi. So I'm going to divide everybody by 4 pi. That will remove the 4 and the pi on this side, which leaves me with r squared. So the surface area is divided by 4 pi. And then to get rid of the square, I'm going to take the square root. So the surface area divided by 4 pi underneath the square root will equal my radius. So this concludes our videos for the spring semester final review. Please let me know if you have any other questions.